Did anybody start the review packet?
I printed it out.
Okay, I'm just trying to,
Just so you know, it's not only your class, that's our class.
I'm trying to decide has anybody at all started? Because I don't want to go over the first 15 questions if there's people in here that already did the first 10, and that would be repetitive. I could work from the back towards the front.
I did like the
Well, they're all mixed in, so I can't exactly do that.
I looked at it, I was like, wow, this is hard.
All right, we're gonna go from we'll go from the back forward anyway. So, before we start, Colin and girls over in the corner, as we go through this, there are really three categories of things that are on your test tomorrow. There's understanding the first derivative and how it plays into, I'll write this down, the first derivative and how it plays into increasing, decreasing intervals, along with how it plays into relative maxes and relative mins. And that's first derivative stuff. And then the second derivative stuff is all about concavity and how to determine points of inflection where concavity changes. And then the third piece that's covered is really graphs of functions and how they compare to graphs of their derivative and how they compare to graphs of their second derivative. So kind of looking at different graphs, maybe starting with a function and looking for the graph of its derivative, or starting with a derivative and looking for the graph going backwards of its function, kind of being able to go any way with these. BC?
Are we going to have to actually graph them, or just going to have to pick them?
Well, it'll be multiple choice questions based on this. So, I sketch graphs often anyway, but you won't be graded on that part. Aiden?
Remember that sheet you were talking about where you were just writing down
yes.
Ideas?
I still have that sheet, but that's mostly quiz stuff. This would really be my sheet, I guess, my little cheat sheet. In any case, you're going to set the first derivative equal to 0 or undefined, and that's going to give you your critical points for something potentially happening in this department. Same thing with your second derivative. It's going to give you your critical points for where concavity could be changing, but doesn't necessarily have to be until you set up a sign chart and look at your intervals of plus, minus, minus, or minus, plus, and realize. In a first derivative, this means increasing and then decreasing, so this would be a relative max. This means decreasing and then decreasing some more, so we don't have a relative min. As far as concavity in the second derivative is concerned, a negative just means concave down, and this is not like a relative max or min or anything. It's just if it's concave down prior and concave up afterwards, this is probably a point of inflection. So this just tells you point of inflection. You don't have to get more specific. This gives you a point of extrema, but you have to get more specific typically as to whether or not it's a relative max or a relative min. You don't have that to deal with on a point of inflection. Any other questions before we start with the review sheet? Lily?
Oh, what was the first day of notes from this test?
Post-Rolle's theorem. So, I guess not. Post-Rolle's theorem, which would be post-Rolle's theorem. So the first day is like increasing, decreasing, and first derivative test.
Okay.
And then the second derivative concavity day. It's really not a lot. It's just the second half of this chapter. And like I said, the curve sketching is not on there. Okay? All right, so The style of these questions obviously different than the straightforwardness, but you have the concepts, you just need to apply the concepts in order to be able to answer them. So you need to understand them fully instead of just being machines who memorize steps as to how to do things. Because here we have a table, and presented in the table are the derivatives, aka the slopes, of 3 different functions at any given point in time. And which of these functions must have a relative maximum somewhere between -3 and 3? So if I zoom in closer to the graph, which one must have a relative maximum? And take a minute quietly on your own to try to think about that. Emma, what do you think? G and H. So what about G? Or explain your answer, I guess.
The graph of the derivative passes the x-axis on both sides from -0 to -0.
So it has to have a slope of 0 in order to have a relative maximum. Is that what you're saying? True. It does have to have a slope of 0 in order to have a relative maximum, but just because it has a slope of 0 doesn't mean it has to be a relative maximum. It could be a relative min.
Yeah,
Say that one more time.
G prime is actually the minimum, not maximum.
Right, G prime, the fact that it's a negative slope first and then goes to positive, a negative slope and then it goes to positive, suggests that G prime has a minimum. We want a relative maximum, so we want the slope, it has to at some point change from positive to a negative. In order to be a maximum, you've got to be increasing and then you have to be decreasing. So in H, you have it increasing and then later on it changes to decreasing, and so there's your indication that there's a maximum at 2. And then in the F prime, it's increasing the entire time. So we don't really have any decrease change there, so there's no way there could be a maximum in F. Does this make sense? Okay? To get a maximum, you need to be increasing and then decreasing, which means you need a positive slope followed by a negative slope, and we only have that in H. Okay? And I gotta erase. I don't know why this thing is so skippy, but it is right now. Hey, here is the graph of the derivative. This is the derivative graph being shown, f prime of x. They're asking a question about the original function f. At what value would the original function have a maximum? Tyler? -2. What's making you say that? Right. So the derivative, given that it's above the x-axis, the derivative is positive here. So it's increasing up until -2. At -2, our derivative or our slope is 0. Beyond -2, our slope is now negative, so it's turned around. And our slope remains negative until we get to 1, at which point we have a slope of 0 again. And then after which we still stay in the negatives. So our graph is still going downwards despite kind of evening out at 0 for a quick moment. So at what value do we have a relative maximum? -2 is correct, where the derivative or the slope goes from being in the positives to being a slope in the negatives. Does that make sense? Yes? As far as the sign chart is concerned, right around -2, which is where the derivative equals 0, and we also have something right around x equals 1, where the derivative equals 0 as well. Prior to that, your derivative prior to -2 is going to yield a positive. After -2 is going to yield a negative. And after 1 is also going to yield a negative. So we have a relative maximum at -2. Any questions on that? Okay. 34. We have a function, and we want to know where is there a relative maximum. So if we're looking for relative maximums, what derivative are we interested in, Tyler W? The first. What do you do with the first derivative? Correct. So the first derivative here is going to be 12x squared minus 6x. And we set the first derivative equal to 0 or undefined in order to find critical points to set up our number line. It's never going to be undefined, so we pull out a 6x. We're left with 2x minus 1. Anthony, where are our critical points? 0 and 1/2, good. And then what do we do once we have that number line set up, Eleanor? Plug what in? Okay, numbers less than 0 into the derivative. So since we're going into the derivative, we're analyzing whether or not it's increasing or decreasing. We're analyzing whether the slope is positive or negative. So if I plug in -1, I'm going to get a negative times a negative, which is a positive. If I plug in 1/4, I'm going to get a positive times a negative, which is a negative. And if I plug in 1, I'm going to get a positive times a positive, which is a positive. So which point is a relative maximum? Not 1/2, because it's decreasing going into it. It's decreasing going into 1/2, and it's increasing coming out, so that's a relative minimum. But at 0, it's increasing going in and decreasing coming out. So that's your relative maximum at 0. Any questions on that? Okay. Let's go through 33 statement by statement and decide if it's true or false. If a derivative at A, in other words the slope, is not defined, then A is not in the domain. Is that true or false? If you have a derivative that's not defined, does that mean that A is not in the domain? What's your gut say?
False.
False. Good. It is false, because there are moments when it's true, but there's at least one moment where here we have an A value, the derivative is not defined there, but yet A is still in the domain, right? So there would be a counter example. So it might most of the time be true, but it's definitely not always true. B, if that's the second derivative. So if the second derivative is positive, what does that mean? Second derivative tells you about concave up. Good. So if that's true at some point A, and A could be anywhere on this curve, then the graph of the function f is concave down at A. False. That's just backwards, right? pretty clearly backwards. In C, we have if the derivative is 0, now the derivative can be 0 like this, derivative could be 0 like that. Any of these moments have a derivative of 0. But and the second derivative is positive. Which graph would that be? First one, right? Second derivative is positive would mean that this is the concave up situation. Here we would have a second derivative that's negative. What would our second derivative equal here? Neither. It would not be positive, it would not be negative, it would be 0, right? Because think about the slope, the second derivative is the slope of the slope. So the slope here is 0. The slope of a 0 slope is 0. Yes? So our derivative would be, our second derivative would probably equal 0 there because that's a change in concavity. It's going from concave down to concave up. So we're dealing with this picture, is the point. Does that then mean that f of a is a relative maximum? No. Here's D. If the derivative is 0, again, we've got 3 options, then the function has a relative extrema at A. Is that true? False, because of, no, this example. Here our derivative is 0, but yet that's not a relative extrema because it's increasing going in and it's increasing coming out. Do we follow?
Yeah.
And E says if the derivative is 0, if the derivative is 0, one of 3 cases, we've got our second derivative is positive, so we're dealing with concave up, then f of a is a relative minimum. Yes.
I couldn't all be false.
Stop being obnoxious, Tyler. Number 32. We're given a function. We're asked where it has a critical point. How do you find critical points? First derivative. F prime of x would equal 1/2 for the 1/2 x. What's the derivative of sine? Cosine. And we particularly need to know where the first derivative equals 0 or undefined. This will never be undefined, so just 0. So I'm looking for where the cosine of x equals negative 1/2. Only looking at the interval from 0 to pi. So I'm only going through the first 2 quadrants. First of all, since cosine is negative, which quadrant am I in? The second. What's my reference angle for when the cosine equals 1/2? 60, which is pi over 3. And so if this is 3 pi over 3, what's the second quadrant version of that? 2 pi over 3. So your critical point would be at 2 pi over 3. Good? Any questions there? All right. Number 31 is giving us a function, and it's asking us about, and you have to look at the solutions to see what they're getting at, about maxes and mins. So which derivative are we concerned with? First. So our first derivative, 16x minus 8x to the third. We set the first derivative equal to 0 or undefined. To set up our number line, we take out an 8x. We're left with 2x minus x squared. Nope. 2 minus x squared. You get x equals 0 or x equals what else? I'm going to have to add x squared over. Plus or minus radical 2, yep. So that sets up 0, root 2, and negative root 2. And again, I'm trying to find maxes and mins, so I want to analyze increasing, decreasing for each interval. If I plug in a negative 2, I'm going to get a what times a what? If I plug in a negative 2, I'm going to get a what? Times a 2 minus negative 2 squared. Negative 2 squared will be 4. 2 minus 4 is a negative. So negative times a negative is a positive. So we start out increasing. And then if I plug in negative 1, I'm going to get a negative times a positive, which is a negative. If I plug in positive 1, I'm going to get a positive times a positive. Positive times a positive is a positive. And if I plug in 2, I'm going to get a positive times a
Colin, wake up.
Come on, man.
negative. So, I'm increasing, decreasing, increasing again, decreasing again. My graph looks something like that general shape. So what do I have? How many maximums?
2.
How many minimums?
1.
So option B. 30 is a tough one. I also ranked these on a scale of 1 to 5. I think I gave this one a 4. There's a couple 4s on your test, but it's mostly 1s, 2s, and 3s. I don't think I put a 5 on your test because I was feeling very nice. But they're asking you to figure out for what value of K we have a relative minimum at 2. So Colin, how do you find relative minimums?
First derivative,
And what is my first derivative in this case?
2x plus the quotient.
Well, you don't have to. I'm going to rewrite my original like this. So 2x and then what? No, this is my original. So if my derivative is 2x and then what? No. K is a constant. You don't. You just do a power rule because it's like it's a 3 or a 4 or a 5. You just bring your... Yes. Negative kx to the... negative 2. I always drop that by 1. So, in order for a derivative to yield a relative min or max, Colin, it needs to equal what? 0 or undefined. Now here it is equaling 0, but it could also equal undefined, yes? But it's only going to be undefined if x is what? 0. But they're telling us they want the relative min to be when x equals 2. So the goal is not here to find the x values, the goal is to find the k's. So if we know x has to equal 2, then this will never be undefined. But if x equals 2, here, we can solve for k. I'm just going to add this k over 4 over, so it'll be 4 equals k over 4. Multiply both sides by 4, and what does k equal, Colin? Good. Which is option A. I'm going to skip 29 for now because it's a definite 5. It's a similar problem, but a weird wrinkle comes up, so I'm not going to go crazy over it. Number 28. What do I do to find... Outline the steps for me. I'm not going to do them here, but outline the steps for me, Elliot.
You're gonna find the first derivative,
Okay.
and then you're gonna take your critical points from on number line and type numbers from
Correct. And I'm going to be looking for what to happen in order for a relative minimum to come up.
a negative slope going to positive.
Perfect. Well done. Good. And then that would, whatever, your number is going to be your relative minimum. Okay? Any questions on that? Well explained. Okay, here's, in my opinion, I think the graphing ones are the hardest, so I'm going to give you a minute to try to answer this on your own. So take a minute to process. I heard they're not good if you just got your wisdom teeth out. Mackenzie, what do you think? Where will the function have a relative maximum? What'd you say? X equals 3. Does anybody oppose? All in favor?
All in favor.
Good. So my suggestion with these, if you have trouble wrapping your head around them, is to sketch a potential graph for the function. So going backwards is the challenge here, because your derivative starts off positive, in the positives, which means your graph needs to be increasing at least up to here, where at the moment the slope should be 0. So my slope is 0 right here. After that moment, my graph is in the positives again, so it's increasing again all the way to 3. So I'm increasing again all the way to 3, at which point I achieve a 0 slope just prior to my derivative going negative, and so now my slope has to turn backwards, and you have a relative max at 3. Good. Does that make sense? Good job. Okay, 26 asks how many critical points are also relative extreme points. So you'd find your critical points, you'd put them on a number line, and then you've got a test. So if you have something like this, and there's 4 critical points, what is going to cause a critical point to not be a relative extreme? Correct. There isn't a change. So in other words, if it's a negative, decreasing, followed by a decreasing again, you're not going to have an extreme point. You're looking for any fluctuation from negative to positive, or vice versa from positive to negative. So, and if I did another positive here, this would be a relative min, this would be a relative max, that would be a relative min again. But this is nothing because we had no change. So we only would have had 3 relative extreme points. I don't know what happens here, but just to outline that problem, does that make sense? Okay? Go back to 25. I think 25 was either on your quiz or on your review sheet. It looked familiar to me. So they give you the derivative and ask you how many critical points. Critical points are just where that derivative equals 0. So the numerator, when you set it equal to 0, is going to yield 2 points. You're going to set that equal to 0, subtract the 4 over, divide the negative 9 over, and square root both sides, which is going to give you plus or minus something. So that's going to give you 2 critical points. And your denominator, the only way your denominator is going to equal 0 is if x equals negative 3. So that's going to yield another point. 2 from where the derivative equals 0, 1 from where the derivative is undefined, so 3 critical points. Okay? Relative minimum is asking you about the, which derivative? First derivative. This one's a little bit more challenging just because the first derivative requires the product rule. But once you have that first derivative, you set it equal to 0 and undefined, you set up your number line, and you're looking for any place where it decreases and turns into increasing on your intervals. And when you find anything like that, that's a relative minimum. Any questions on that? Okay. Point of inflection should scream second derivative to you. Okay, so we'll do this one. So your first derivative is 40x to the 4th minus 20x cubed. Your second derivative is 160 x cubed minus 60x squared. Your critical points as far as the point of inflection is concerned is going to be from where this equals 0 or is undefined. It's never undefined. We factor out a what? Maddie? That's going to leave us with 8x minus 3. So we have a critical point at 0 and at 3/8. So 0 and 3/8. We're going to test now. We're testing for changes in concavity. So when we test points, we're testing it in the second derivative to analyze concavity. The first term is always going to be positive, no matter what x is, yes, because we're squaring it. So when you plug in a -1, it's going to be a positive times what's going to happen if I plug in -1? A negative, and a positive times a negative means negative, concave down. What can I plug in between 0 and 3/8? 2/8 or 1/4. Perfect. So that's the same thing. We'll plug in 1/4. It's going to be a positive times, what's 8 times a fourth? 2. 2 minus 3 is a negative, so that's going to be a negative. Is that a point of inflection?
No.
No. And then I got to plug in something after 3/8, like 1. If I plug in 1, I'm going to get a positive times a positive, which is a positive. Is that a point of inflection? Yes. So how many points of inflection? 1. Sometimes they ask you how many points of inflection. Sometimes they ask you, where are they? We obviously can read into that difference, yes? 22. How are we doing? I know, but this is your test prep. You want to try, do this one on your own. Go. Do it on your own.
I'm on it. I don't want
It's too boring if I do it all for you, so I want you to try this one on your own. Go, Tyler.
What? I can't do full questions right now. Next, I can't even do this one next.
Would you stop it? Oh, I don't have anything to say to him anymore. I'm going to put him way over there.
What are the choices?
Function f is twice... I'm going to give them to you in a minute.
I only answered to the process of elimination.
Function f is twice differentiable such that f prime of x is less than 0, f double prime of x is less than 0 for all real values of x. If f of 1 equals -10 and f of 2 equals -15, which of the following could be a possible value of f of 3? So, before even answering that question and me showing you the answer, sketch this to the best of your ability. We're playing teacher with it. I'm collecting it.
What is this?
A 5.
I don't know, 5.
Easily a 5.
Sketch it.
What is it? Tell me what it is.
4.5.
Sketch it, and then I'll tell
Do
you.
I look at the choices?
No, not until you show me a sketch.
Basically a 5.
Teamwork.
Beginning to, we gotta believe that every time we between X and negative 15. This is the last they use. After 10th grade, math is just a 6th grade. Like normal.
Can you draw a picture, or else I'm taking away a point? If you don't have a picture done, when I call on you,
What point do I have to take away?
you have a quiz I could take a point off of.
Yeah, possible. What is it really the first derivative? What is that?
What's another name for the first derivative? Slope.
Oh, gotcha, sorry. Like, Out of all the ones we just did together, you picked the hardest one for us to back.
You say that, that's because you haven't processed anything on your own yet, because you're just,
You know I was answering that.
you were.
Hey, we got something written down? Well,
Did you not copy Jake?
I'm collecting 3 graphs.
Okay.
Hannah, I need 3 numbers between 1 and 19. What'd you say?
3, 7, and 10.
I just saw you looking at me. That's so nice.
No, I just felt someone looking at me, so I looked over and there you were.
No, no, I felt you looking at me and I looked up and you.
I was looking at the board.
yeah.
You are lucky, Tyler.
Why?
Because I get to take yours and look.
You sure Jake won it?
Yes.
Thanks a lot.
So we need something such that the slope is negative the whole time. So, a negative slope the whole time, and the second derivative is negative the whole time, so it's concave down. So, all 3 of these people have a good graph. That's negative the whole time and concave down. That's negative the whole time as a slope and concave down. That's negative the whole time and concave down. So in every single case, and you don't obviously need exact numbers, but in every single case, this person went through 1 negative 10-ish, and also went through 2 negative 15. Got it. Now, which of the following could be a possible value of f of 3? So, the slope here is what? It's negative, but more specifically, 1 negative 10 to 2 negative 15. So we drop down 5 and over 1. So there's a slope of negative 5. In order for the concavity to stay opening down, it needs to get, is this getting more steep or less steep? More steep. So we need whatever is going to be paired with 3. We need to make sure it gives us a more positive slope than negative 5. So the most extreme one would be this one. So that would be your safest bet.
Oh, that's a great way to answer something on a test.
Why couldn't it just be like,
Hold on.
there's only one that's less than this? This might.
Because if it's negative 20, then it's linear, and there's no concavity. 1 negative 10, 2 negative 15, 3 negative 20 would be a linear drop, which we don't want to happen, because then concavity doesn't exist. Do we follow? So the only one that, then your concavity is getting less.
What's the rank of that question?
That was a 5.
Yeah, exactly.
Oh.
It was.
Straight to my face.
I didn't know until I looked it up. Pass this back, please.
It's good enough.
That was a 5. Not because of the drawing, but because of the specific things that they picked at Y coordinates. I was just hoping it would be the only one less than it, but it was less than it.